little tough to see on the screen there. Just a couple of quick notes for you. For those that took their Unit 2 test last week, maybe you've seen the grades are in the grade book. It's all graded and ready to go. There are a few folks that have yet to take that test. And so for those folks, we'll be getting those done here shortly. Once everybody's done with it, which should be in the next day or two, we'll get those back to you so you can see specifically what you did. If, however, you are just like dying to see the specifics of your test, you're welcome to do that. You could drop by during lunch period. I know today after school I'm going to be here for quite a while. So if you really, really wanted to see that because you're curious, you're welcome to do so. We'll hand those back as a group, maybe tomorrow. We'll see. Anyways. One, 2, and 3. And for goodness sake, please ask a question if you have a question on 1, 2, or 3. And then we'll kind of set 4 aside, and I'll do that one with you. Since that's the newest of this group. So here's the answers for 1, 2, and 3. So 1, I showed a lot of work up there. I think the final answer for number 1 should be 26. For number 2, my final answer is over there on the right. I'm putting it in a blue box right now. And then I've got the graph. And then for number 3, okay, that one is fairly self-explanatory as far as what I think the answers ought to be. Okay, so this is your chance to kind of look things over. I'll just wait patiently for you. I'm really hoping I get a chance to talk about number 1. Because just peeking over shoulders, I feel like our PEMDAS skills have kind of fallen off the map a little bit. Yeah, and I don't know about 2 and 3. I feel like, I don't know, we'll see. Okay, so let's not make this a time where all you do is just copy down answers. Just copy down answers. The only thing that really means is that you know how to write, which is good. We want to go a little deeper than can you copy down what the teacher wrote. So I'd love to answer some questions from you on any of these. I'd be happy to rework any of them or whatever.
Could you rework number 1?
Happy to. I like number 1. Okay, so let's focus in on number 1 here, and I'll try to give myself lots of room. So y'all remember when you're trying to evaluate something like this, the first thing you should do is replace all of the variables with empty parentheses, right? That's where we start. So I'll start there. So it would be 8 minus empty parentheses, open parentheses, negative 2 times empty parentheses, bless you, plus absolute value of 5 times empty parentheses, quantity squared times 2. There's a lot going on in this. Like if you can handle number 1, you're doing awesome. Number 1's tough, for sure. Okay, so make sure you're paying attention. Make sure you're paying attention to number 1 here. So now what I'm going to do is I'm going to fill in all those blanks with what belongs there. So x is negative 1. That goes there, and y is 4, so that goes there. And walking around, I think the vast majority of you guys had that. Can I point out, is it okay with you if I point out some errors that I saw that were common? Walking around, I saw there were a fair number of folks that looked at this and thought to themselves, hey, 8 minus negative, well, that's really 8 plus 1, right? And what's 8 plus 1? And so I saw a lot of folks that at some point or another had a 9 right there. That's definitely out of order of operations because isn't it negative 1 times all that stuff? And if you did that, you did addition and subtraction before you did multiplication. So we can't do that. So we're going to leave that alone. Remember, I said this before, I think it bears repeating. In math, we do not read from left to right. If we have multiple operations going on, we read according to PEMDAS. And PEMDAS says do work inside parentheses before you do anything else. And I'm sure y'all can see there's a lot of work to be done in the parentheses, right? So what I would do first is 8 minus negative 1. I would resist the temptation to simplify that. And in the parentheses, I've got negative 2 times 4. That's negative 8. And then over here, I've got 5 times negative 1. That's negative 5. But what's the absolute value of negative 5? 5. So I would have just plus 5, that whole thing squared, times 2. Please notice I'm trying to show orderly, neat steps. I am definitely not just like throwing things out there, trying to be neat and organized. So am I done with all the work in the parentheses? I think not. Do you see there's work to be done right there? So this would be 8 minus negative 1 times negative 3 squared times 2. And I would say now I have done all the work in the parentheses. I'm done with that. What comes after p? Right? Exponents. Yes. So there's one exponent in there. So it's 8 minus negative 1. What is negative 3 inside parentheses squared? It's positive 9. Yep. So times 9 times 2. And then I've cleared all my parentheses work. I've cleared all my exponents. I'm down to multiplication or division. There's no division, but there's multiplication. It's all right here. Negative 1 times 9 times 2 is negative 18. So it would be 8 minus negative 18, which is really 8 plus 18. And there's my 26. Oops. All right. What do y'all think about that? There's the live version. Any takeaways? Did I do anything just now that you're like, whoa, I didn't think about that. I should do it. I mean, you want to share? Anything strike you as like this would be helpful?
I did 9 in the beginning.
Say again?
I did 9.
You did the 9 at the beginning? Yeah. It's so tempting, right? You see that 8 minus negative 1, and you just want to go like 8 plus 1, right? And we're done. Notice how I didn't do anything with that 8 until the very, very, very end. Because in math, we don't read from left to right. We just don't. Unless it's just one operation, right? If it's multiple operations, we do PEMDAS. In a second.
Okay.
Anybody else have any feedback or questions on number 1? Bree.
Well, this is kind of a rookie mistake, but I plugged in 2 for 5 times negative, sometimes x, but I saw I don't know why I confused the 2.
Oh, you saw the 2 on the outside?
Yeah.
Oh, okay. Yep. And, you call that a rookie mistake. I just call that you might have been slightly distracted or in a rush or something. So that's a be careful mistake, right? Yeah, for sure. Thanks for sharing that, because how many times have we felt like, I don't understand this at all? And the truth is you do understand it, but you made the rookie mistake and it's making you feel confused. It happens. It happens. Yeah, thanks for sharing. All righty. So number 2. So Sebastian and perhaps others with number 2. It says, solve the inequality and graph the solution. So you remember that solve means get the x by itself. And so my first thought when I looked at this was, the x is definitely not by itself. I see that negative 2 being multiplied by it. So my instinct, as you maybe saw, was I want to get rid of that negative 2 before I do anything else. So Sebastian, does it make sense to you that I would divide by negative 2 to get rid of that negative 2?
Yeah.
Because it's negative 2 times the parentheses with the x? So that means you can't just do that. You need to divide everything by negative 2. Yeah. So divide this by negative 2, divide this by negative 2. And this is where the trickiest part of this one shows up. If you divide everything through by a negative, what do you have to do with inequalities? Yeah, they got to flip around. So this is negative 3, but the inequality now is that. X minus 1 remains, but the inequality over here now is this. And of course, 12 divided by 2 is negative 6. So the inequality's got to flip when I divide everything through by a negative. And then, again, trying to get the x by itself, clearly there's a minus 1 with it. So I would go plus 1 to get rid of that minus 1. And like you said earlier, whatever I do to one part, I've got to do to, or one side, I've got to do to all the sides. Because this is a compound inequality, so it'd be negative 2 is greater than or equal to x, which is greater than negative 5. And I could write this the other way. I could say negative 5 is less than x, which is less than or equal to negative 2. That's saying the same thing. And then how about getting it onto a graph, Sebastian? Are you okay with getting it onto a graph? Open, closed? Okay. So open and closed. All right. Any follow-up or feedback on number 2? All right. How about number 3? We doing okay with slope-intercept? Okay. How about number 4? I didn't give you any answers for that. Let's do number 4 together. Excuse me. So number 4 is right here. And notice how number 4, it tells us the way we're supposed to do this. It says, solve this system using elimination. And I will do this from time to time, like say on a concept quiz or a test or something. I'll say, I want you to use substitution. Just so you know, if I say I want you to use elimination, that actually means that elimination will be a relatively easy method. I'm not going to say, ooh, what would be the hardest way to do this? Let's do it that way. I'm not going to set you up for failure like that. I'm going to say, hey, this would be an easy way. Do it that way, just so you know. Because this one could be done by elimination or substitution, but it's a fairly straightforward elimination. So in order to do elimination, you need to have the pattern of opposites on either the x's or the y's. Pattern of opposites be like negative 7 and positive 7, 4 and negative 4, that kind of thing. You notice how the x's don't have that pattern of opposites? It's 3 and 5. What about the y's? Do they have the pattern of opposites? Okay. Of those two, the x's or the y's, which would be the easier to create the pattern of opposites? The y's for sure, yeah. So if I wanted to create that pattern of opposites, I would need to multiply which equation, the top row or the bottom row? Top row by what? Negative 2. It's got to be opposites, right? So if I multiply this top equation by negative 2, I'll just write the result down below. Sir?
Why do you choose like 2? Why don't you do the 3?
Because I need, well, okay, so I need the pattern of opposites. So pattern of opposites would be things like 7x and negative 7x, or negative 11y and positive 11y.
2 would make the, yeah, I understand. Yeah, okay.
So I want my y's to have that pattern of opposites. My bottom y is 2y, so I want the top one to be negative 2y. Okay. So this would give me, and don't forget to do this to all of the terms in that top row. This would be negative 10x minus 2y equals negative 4. So notice how I multiplied all three. I distributed that negative 2 onto all three of those terms. Okay, so once I've done this, I just add. And what is 3x plus negative 10x? That was a question. Could you guys answer? Negative 7x. There we go. What about positive 2y plus negative 2y? It's not y. It's actually 0. So if I wanted to, I could put plus 0. But I rarely will put that. Doesn't this mean that the y's have been eliminated? That's why it's called elimination. And then what is 11 plus negative 4? So I end up with this. And now I'm going to just solve. So divide everything through by negative 7. Therefore, x equals negative 1. How are we doing? I'm done, right? Oh, I'm only halfway done. I need to find the y to go with that x. How do I find the y to go with that x? I plug in. That's right. So I'll just come over here and I will plug in. I've got 3 equations. I've got a red equation. I've got a blue equation. And I've got a yellow equation. Of those 3 equations, which would be the easiest to plug back into? Red is easiest. I agree. So it would be 5 times negative 1 plus y equals 2. That's really negative 5 plus y equals 2. So what do you guys think y equals? 7? So my answer would then, if that's the case, my answer would be negative 1 comma 7. Negative 1 comma 7. We do that right? We good? Follow-ups, questions on number 4? No question, yeah, Sasha, go ahead.
And I just did it the other way, so I multiplied 3 by 5, and then the top equation by negative 3, and I got the same answer.
Perfect. It's a great example of how you could take a very different looking path and still be correct. Totally fine. What do you have against x's anyway? Do you want her to eliminate them? I eliminated the y's. It's all good. Okay. We're going to practice this all week. Wherever you are now, let's get better. Hey, one thought. And I refuse to try to make you do this because I think you should be able to do this on your own. If at any point you're ever disappointed with DMR quiz grades or you think, I want to do well on this, man, I'll tell you, a great way to do this would be to Wednesday afternoon, Thursday afternoon, whatever, go back and look at the DMR practices for the whole week and do them again. And if you didn't get them all right, what should you do? Do them again. And keep trying until you can. That makes sense? If the class practice is enough for you, that's awesome. If it's not enough for you, be honest about it. It's not enough for you. And do a little more practicing. Be happy to be a part of that. Most lunches this week I should be free for at least part of lunch, if not the whole lunch. Come in. You know where to find me. Should be right here. Okay, cool. Hey, today's going to be a little bit of practicing of what we did last week. I'll remember how we did, let me put it like this. Remember how we found where the shadings overlapped? Mm-hmm. We're going to practice that again here today. So I'm just going to set you guys on your path here. I think we got like 3 examples. Yeah, 3 examples. We'll do as many of these as we can. I definitely want to do numbers 1 and 2. And I think in 20 minutes we should be able to for sure do that. So please try number 1. Work with a partner, work on your own, compare answers later. I'll be around to help as needed. Ready, set, go. You stop me if I go too fast or if I say anything that's at all confusing. Please stop me. I'm not going to be upset. I'm not going to be sad. I'll do my best to re-explain myself. So this top line right here, I'm going to graph this in blue. Did y'all recognize that top line is horizontal? It's only got a y. If I tried to ski it, I would say, why would I ski that? That's one way to look at it. The other way to look at it is every y coordinate has to be negative 3. And so right here, this has a y coordinate of negative 3. So does this, so does this, so does that. All of these points have a y coordinate of negative 3, don't they? The x coordinates are going to be whatever they're going to be, but the y coordinate has to be negative 3. That is the pattern we're looking at. And are you guys okay with that being a dotted line?
Yes.
It does not have the or equal to on the inequality. And since it does not have the or equal to, we've got to leave it as a dotted or a dashed line. So this is where, if you look at that and you're like, gosh, why did he leave that a dotted line? I don't know. This is where you'd say, why is it dotted again? Right?
Because it's not equal to or equal to.
Yeah, it doesn't have the or equal to. You know, the trick way that people have used in the past, they've said, if the inequality requires more ink, then my line requires more ink, right? And the inequality does not require extra ink, so our line doesn't either. Shading. I'm going to test out the thing that we always test out, 0, 0. So this would be 0 is greater than negative 3. We have to decide, is that true or false?
That's true.
It's totally true. Yep. So since that's true, I'm going to shade on the 0, 0 side. And so that would look something like that. How are we doing? So far, so good? Any questions? Okay, and then the other one I'll do in red. What kind of a line was this other line? Vertical. Vertical at 2. So here is x equals 2. Here's a bunch of other x equals 2s. Should I leave this red line as dotted, or should I turn it into a solid line?
Solid.
Why?
Because it's equal to.
That's right, we got the or equal to in there. So here's what it could look like. Like so. And I'm going to test out 0, 0. So that would be 0 is less than or equal to 2. Is that true?
Yes.
It is true. So I'm going to shade on the 0, 0 side. And so shading on the 0, 0 side would give me this. So I'm looking for where the shadings overlap. Can you see where that is? I would, if there's any confusion, you could just say, this is my answer region right there, kind of that upper left-hand corner. Try to make your answer obvious. You know, like I look at Ella's there, and I'm like, I really can't tell what her answer is. And then she writes that, and now I can tell. You know, Anya's I can tell because that's the one that's mostly the one that's shaded, and the other parts aren't. Oliver, I look at yours, and I don't have a clue what your answer is, just because all the shading looks about the same. You know, Noah, that's making sense. Yeah, Sydney, that makes sense. So please make it clear. Like if you look at it and you say to yourself, I just don't see how anybody could tell what the answer is, then I can't tell either. And I'm not going to just guess. So please try to make it as clear as you can. If you got to put answer in that region, then put answer. Okay. Questions? Okay, like I said, I definitely want to do at least one more, and I think we have time to do that. Let's look at number 2. Number 2 is a cool one because number 2 does not involve 2 equations. It involves 3. They're all nicely in slope-intercept form. So you guys I'm going to give you about maybe 6-7 minutes to work through this one, and then that'll leave me about 3-4 minutes at the end to show you a solution to it. So take your time. Top line I'm going to do in blue. So this one here, the y-intercept is 0, 4, and the slope is negative 1/3. So I think for this line I would go down 1, right 3, down 1, right 3, or I could go up 1, left 3, up 1, left 3. So for that top line, should I leave that top line dotted or should I connect it with a solid line? Solid line, because it's got the or equal to. So I've got to go solid line here. And here is my attempt at that. There we go. I prefer personally to shade as I go, so I'm going to shade this right now. So if I test out 0, 0 in my blue line, I get 0 is less than or equal to negative 1/3 plus, or sorry, negative 1/3 times 0 plus 4. That'd be 0 is less than or equal to 4. Is that true? Yeah, 0 is less than or equal to 4. So I would shade down below where the 0, 0 is. Yep. So I'll shade all this stuff like so. Okay. So far, so good?
Yes.
Next line in red. So this line is conspicuously missing the x. So if your line only has a y, what kind of line is it? Horizontal. It's flat line, yeah, horizontal. And it's at 1, so that would be all of these points in here. So with this one, should I leave this a dotted line like I have it, or should I make it solid? Why dotted? That's right, there's no or equal to, so I leave that dotted. Shading, I'm going to test out 0, 0. Here I get 0 is greater than 1. Is that true? That's not, it's false. And so that means I'm going to shade away from 0, 0. I'm going to shade on the other side. So I'll be shading up here. Can you start to see where my answer region might be? It's sort of a triangle-y looking region in there. And then I graph my final line, which I will do in green. Here the y-intercept is 0, 6. That's up there. My slope is 3 over 2. The hard part is it's hard to go up 3, right 2, isn't it? So instead of going up 3, right 2, I'm going to go down 3, left 2, down 3, left 2. Oops. How about there? Down 3, left 2, something like that. Should I leave this line dotted or should I make it solid? It's got to be dotted. It does not have the or equal to. So I'll just leave this a dotted line. And then the shading, this is going to decide it all. I'm going to test out 0, 0. 0 is less than 3/2 times 0 plus 6. 0 is less than 6. Is that true or false? 0 is less than 6, isn't it? So that's true. So I'm going to shade on the 0, 0 side. And isn't the 0, 0 side over here? The side containing 0, 0? And so I'm thinking my final answer is going to be this region right here. Kind of looks like a triangle again, but it's that little part bounded in that section. Okay. Really encourage you, as you're working through your web assignments, you'll find a decent number of these. You probably already found 1 or 2 on a couple of your assignments, or maybe at least 1 from last week. Hope this goes well for you. I got one final announcement for you. You've probably seen this coming up on Schoology. I think this is the last one. We have an intro video for tomorrow, and that intro video is a little refresher on middle school concepts with percent. Okay? So a little review on what percent is all about, and then our next 2 class days will be spent working on percent. So hope you guys have a good rest of your day. See you tomorrow.